Welcome back, Akira Bike Project fans. We left off the last video working on the frame update to handle the additional foot rail and starting on those foot rail bearings. With the frame now able to handle that third rail, I figured it'd be good enough for testing and I can revisit the electrical adjustability and bearings later. So I decided to go ahead and move forward. With the frame flipped back upright on the work stands, I started sanding and cleaning it while deciding on what to tackle next. Do I go ahead and mount the engine before final welding the frame? Final weld the frame first? How will I keep it from warping and ensure the front and rear alignment while welding it? The position of the engine will also be critical in determining the position of the next and last major assembly, the reduction cage, which is essentially a big single gear transmission that reduces the output of the engine speed to accommodate the large diameter rear tire. I decided to proceed with fit testing and tacking everything until the full bike is assembled, then take it all apart again and do a final weld on it. With that in mind, I started constructing the reduction cage before the final welding of the frame or mounting the engine. I started on the frame for this component, but in the process of laying it out after cutting it, I realized my welding table was significantly warped. This assembly will need to be pretty accurate, posting a pair of sprockets and a bevel gear pair, making it difficult to fabricate on this table. This table has been around a while, so I think it was time to upgrade anyway. After doing some research, I discovered these newer and inexpensive laser-cut ribbed welding fixture tables. Previously, you needed pretty much a solid machined cast iron block to make a good welding table. But these laser-cut rib tables can be quite accurate, yet inexpensive, easy to assemble, and cheap to ship, and filled with tons of 5/8" holes that are great for clamping. The table top is laser-cut with grooves and slots. Clamping the vertical ribs into the table pulls the table flat against the ribs, and the welding is done inside the slots cut into the tabletop, where the teeth from the ribs poke through, instead of under the tabletop, virtually eliminating distortion from welding. So I built up this 2 foot by 3 foot welding table and was quite happy with the result. A significant issue with bringing this bike into reality is scale. If you scale this design to normal sized motorcycle tires, it's way too small and the rider's head sticks out far above the windshield and headrest. However, if you scale the build appropriately for the rider, motorcycle tires become comically small. This has led most builders to just opt for a smaller build, with the consequence of the rider's head sticking way above it. Although some builders have built fake tires that make the small real tires look appropriately scaled and larger. This is also a challenge that feet-forward or recumbent motorcycles will generally face in their design. It doesn't help that the laws in Japan, where some incredible builds are currently underway by some extremely talented fabricators, apparently make it extremely difficult to make custom bikes that are more than 250cc in displacement and 1.5 meters long, which ends up being not much more than a scooter. Ironically, the same Bosozoku motorcycle gangs that inspired the gangs in Akira also inspired the tough regulations in Japan that make it nearly impossible to actually make Kaneda's bike full size. Since I'm not doing a one-off build for looks here, and I'm trying to make a fully functional, high-performance recumbent motorcycle to manufacture, I'm aiming to do this right. To overcome these scaling challenges, at the start of this project I decided to try using a larger diameter aircraft tire, which are some of the only other tires with the rounded profiles that motorcycles need to lean with. In my production design, the bike is absolutely fully scaled and properly sized. Here it is with a rider model approximately my size of 6 foot 2 inches. But with my prototype here, when I was originally designing it, I thought it was fine to leave the headrest lower, since this would just be for testing. But over time this has come to bother me more and more, and I want the prototype to more fully represent the final build. Additionally, with the way this build is progressing, I may very well produce this in something like a kit form, before rolling out the high-end, high-performance, weight-optimized, refined production version. I'm not going to bog down this build in endless modifications, trapping it perpetually in some never-done state while striving for an abstract, unattainable platonic ideal. After all, every single part of this build could be remade and optimized further right now. But I will make the necessary adjustments along the way to make what I think is a viable product, especially if it bothers me this much. With that said, even though I'm using the large tires and have good proportions on the length, I decided I would raise the headrest to get the right height proportions. I thought it shouldn't be that bad, just changing a few bars and welding it back together. So I played around with the design, trying many different iterations, and settled on this. The backrest bars would get angled back slightly more, effectively lowering your head height a little since you would now be leaning back a little more, and the headrest would get raised a few inches. I went ahead and updated the model, and the results came out like this. Overall, I think it's much better, and it balances the front to rear visual weight more, and most importantly, is properly scaled to a rider. Before I started cutting though, I built a full-size wood mock-up to make sure with the rider in the seat, the headrest height still looked good. This wood mock-up is angle and height adjustable to match the current design, the intended design, and a few points of adjustability in between. This is the original design with a steeper rear backrest angle, lower headrest height, and the vertical rear post supporting the headrest at a forward position. And here is the new position with a shallower backrest angle and higher headrest that is moved further back. The new seating position and headrest looked pretty good and felt good, so I proceeded to move on to modifying the frame. I started off with cutting off the old headrest, wondering along the way if I was making a huge mistake, but all the reasoning seemed sound, so I went ahead and moved forward. With the headrest removed, I went ahead and started on the first of the two main backrest bars. These are part of the critical central triangulation that strengthens the frame. This is why the frame is only tack welded still, to allow for easy modifications like this. Still, it's a bit of work to even remove these temporary tack welds. I removed the horizontal rear support for the headrest next, since this would also get modified, and clamped some reinforcing scrap to the frame to keep everything lined up while I worked on it. Next, I went ahead and removed the other side main backrest bar and continued to clamp more scrap bars along the way. And these two parallel center bars in the backrest had to go as well, since the backrest angle was changing and the height of the headrest was increasing. These pieces would be longer and with a different angle cut into them. And of course, these two vertical pieces, where the engine actually mounted to the frame in the front, had to go, since the height of the headrest changed. I was growing anxious with each additional piece of the frame getting removed, with the result looking like this. I started on the new pieces, cutting the main backrest outer angled pieces, and fit testing them on the frame. When I originally built this frame, I meticulously laid up every component and very slowly tack welded and adjusted it along the way, making sure it stayed aligned as best as possible. But now that I'm here cutting so many parts off the frame, I'm going to need to do that again to re-add these parts. It would be much better to use a frame jig. I had designed one a while back in the project, but didn't build it. With all these pieces now removed, I thought about the direction I should go from here. Since it's better to hold these parts rigidly in a frame jig to align and weld them, and I plan on making more of these, and I was impressed with the welding fixture table I just made, I decided it was time to go ahead and build a proper frame jig. I'm going to make this modular frame jig so I can adapt it to my design as needed for future phases, and use it for the production version as well, and make it upgradable to a rotisserie frame jig for easier final welding. I've made separate videos for the frame jig build, and they'll be uploaded just a few days after this one, so be sure to keep an eye out for those. Well, that is it for this video, but please check back soon. The next one is already done and will be uploaded shortly. I hope you enjoyed learning a little bit about the design considerations and the reasoning behind constructing a frame jig for this build. This is a one-step back, three-step forward kind of thing, and I'm pretty sure the last major frame modification, so I'm excited to share this progress with all of you. I'd also like to welcome and thank my newest patron, Calvin, a longtime follower of the project. Calvin, thanks for your support. If you like the project and want to see a fully functional Akira-inspired bike on the road and be able to buy a recumbent motorcycle, please become a patron and support the project. Every little bit helps, and you can contribute as little as $1 a month. Thank you. See you soon.